And we start with letter A. Now, I'll write this out once, kind of longer, and then after that we'll keep it shorter. But if I see 54 and 24, I know that the number 6 divides evenly into both of them, right? And I notice that there's an x in the top and there's an x in the bottom. So I'll write this as 6x times 9x. So everybody agree that 54x squared is 6x times 9x? Then in the bottom, I have 6x times 4. Notice how you have 6x times 9x and 6x times 4. Because it's written as multiplication, I can now cancel the 6x. This cancels, and that cancels. Because 6x divided by 6x is just 1. So that's why we can make it go away. So you have 9x over 4. That's my final answer. Notice in the next part, we do have some addition and subtraction. However, it reads 8x squared times that thing and 4 times that thing. So x minus 3 divided by x minus 3 is 1. So those you can simply just cross off. And we get 8x squared over 4. 8x squared over 4. Is that done? 2x squared. That's my final answer. Sometimes people get to a problem like letter C and they start doing what I call voodoo math. They just make stuff up. For example, x divided by x will go away. 5 divided by 10 is 1/2. And 10 divided by 40 is 1/2. And so they're going to get 1/4, and we'll attach an x squared. X squared over 4. No, that's not, it's nothing right there. Let's get rid of that and redo it. You see, what's different about this problem is nothing is written in factored form yet. What can you factor out of the top? A 5. What can you factor out of the bottom? And when you factor out a 10x, we get, again, x minus 4. Now that it's written in factored form, I can cancel parts. What's going to cancel off? And so we have 5 over 10x. Does 5 over 10x reduce? Yes, it'd be 1 over 2x. Any questions? Okay. Letter D, we're going to switch it a little bit. We're going to go x squared minus 9 over x squared minus 5x plus 6. Okay, so I'm just going to switch that a little bit. All right. When people get this problem on a test, what do you think they're most tempted to do right away? I hope that they're going to factor, but a lot of people don't factor. They go like this. So see why people maybe want to do that? Yeah. But you can't do that because it's not written in factored form. So let's do a divariance. Let's factor the top, and we get and in the bottom, you have a trinomial, x squared minus 5x plus 6. I need two numbers that multiply at a positive 6 that add a negative 5. Good. X minus 2 and x minus 3. Have you seen now that in this chapter you're going to have to be able to factor? Yeah. I won't have you factor cubes. I won't have you factor by grouping. But your 3 basic factoring options, which are difference of squares, trinomials, and then common factor, you're going to have to be able to do those. And so if you want to go back and look at that test and redo that test from first quarter, still can do it. X minus 3 divided by x minus 3, those cancel because that's 1. And you're left with x plus 3 over x minus 2. Can I get rid of the x's? Gone, right? No. No, no, no. Nope, that would be canceling parts again. Again, if you had, say, 3 plus 7 divided by 3 plus 1, you can't just cancel those and say the answer is 7, can you? Doesn't work like that, does it? Nope. 3 plus 7 is 10. 3 plus 1 is 4. 10 divided by 4 is not 7. Okay. So let's be careful with what we decide to cancel off. All right. This is the last thing we'll do, and then you'll be done for the day. Multiply the following rational expressions. We want to be able to multiply. In order to multiply, we just multiply straight across. So 3 times 4x is 12x. And 2x times 9 is 18x. At that point, you can simplify it. However, I choose to do it a different way, a way that I think is a little bit more effective. Can I show you how I do it? What is 3 over 9 reduced to? Close. 1 over 3. What is 4x over 2x reduced to? 2 over 1. So you get 1/3 times 2, which is 2/3. So you can look at, thank you. You can look at the cross, you can look across the top or bottom and try to reduce parts as well. So look at here. X plus 2 is not in the same spot as this x plus 2, but you can look across and recognize that those will cancel. And so we get 4 times x minus 1 over 12. Does that reduce? Yeah, 4 over 12. Same as 1 over 3. If you did, you get 4x minus 4 over 12. But that actually doesn't allow us to see that the 4 over 12 reduces to 1/3. So this is it. 2 more problems. Letter C. Is this written in factored form? Let's factor it. What can you factor out of the top here? 3. And what do I get? 3x plus 1. And then x squared minus 25, how does that factor? I like that. You see some things that are going to be able to reduce, right? X plus 5 and x plus 5, those reduce to 1. 3x plus 1 over 3x plus 1, those reduce to 1. And then I have 3 over x plus x minus 5. Easy to forget about the 3 or to miss something, so try to be neat with your work. Last one, again, this is not written in factored form. How does x squared plus 2x minus 3 factor? Yep, x plus 3 times x minus 1 over, and then x squared minus x minus 2, being x minus 2 and x plus 1, times 2 minus x over x plus 3. Okay, there we have it. What do you see is going to reduce? Can I just cancel off the x minus 1 and the x plus 1, say those are close enough? No. Sure looks like the x minus 2 and 2 minus x, don't those look pretty close? Actually, I can make them the same. Yeah. What could you factor out of this to make it look identical to this? A negative 1. If I factor out a negative 1, what happens to this negative x? It changes to positive x. And then this positive 2 changes to... So it turns out that 2 minus x actually factors to negative x minus 2. So we pulled out a factor of negative 1, which is something we really hadn't tried. What now reduces? X minus 2 and x minus 2. So what you're left with is a negative on x minus 1 and a denominator an x plus 1. Not too bad. So on Monday, we will pick up and we will start by talking about dividing and then adding and subtracting. So we pause there.